Hello, pre-calc honor students. Here we are with 13.1, arithmetic and geometric sequences. Our objective is to identify an arithmetic or geometric sequence and find a formula for its nth term. First, some arithmetic sequences. Here we've got 2, 6, 10, 14, 18. Notice how you keep on going up 4 each time. And this is something called the common difference. So let's add that in here. The common difference, D, equals the difference in two successive terms. So 6 minus 2 equals 4. So we get a common difference of 4 on that one. Okay? Notice on this next one, though, when we take 10 minus 17, notice the order. 10 minus 17, and you get negative 7. So now you've got common differences of negative 7 now for this one. And here, this tells the general idea of an arithmetic sequence. You go from A to A plus D to A plus 2D to A plus 3D. Here, the common difference is just plain old D. So that's the idea of common difference. It tells you by what you're going up each time in the arithmetic sequence. Now, in a geometric sequence, it's a little different. Now we have something called the common ratio. So in this case, I'm going to divide by, to get the common ratio R, it's going to be the ratio of two successive terms. So 3 divided by 1 equals 3. So you get a common ratio of 3 on that one. On this one, the common ratio would be negative 32 divided by 64, which is negative a half. Notice you can have a negative common ratio. And notice the alternating sign there when you have a negative common ratio. And of course, here's the general form: AR squared, AR cubed, AR to the fourth, and you keep multiplying by R. So that's our general test for seeing if you've got an arithmetic or geometric sequence. Look at two successive terms. If they keep the same common difference, it's arithmetic. If they keep a common ratio, it's geometric. Now, you could have neither. For instance, in this sequence, t sub n equals n squared plus 1. Now, t sub n is the nth term of the sequence. That's the output. And n is the index, or the input. N must be a positive integer. So let's do the first 4 terms of this sequence. For t sub 1, we get 1 squared plus 1. So for the first term, we get 2. For the second term, we have 2 squared plus 1, and that equals 4 and 1 is 5. So right now it looks like we have an arithmetic sequence of going up by 3 each time. But let's look carefully at 3. T sub 3 is 3 squared plus 1. And so you get 9 and 1 is 10. Oopsie. 2, 5, 10. So it's not arithmetic anymore. Is it geometric? Well, to go from 5 to 2, that's to 5 to 10, that's doubling. We didn't double here. So you can see it's neither. And if you go to the next term, 4 squared plus 1, and you end up with 17. So up 3, up 5, up 7. What you might notice is that the common differences keep having a geometric arithmetic sequence, and that's eventually what leads it to us deciding that it's a second degree polynomial equation, but it's neither arithmetic nor geometric. So here's the formulas for the arithmetic sequences. T sub n equals t sub 1 plus n minus 1 times d. Where does this one come from? Well, let's look at these all these terms carefully. Make this a little bigger. And so to get to the nth term, that's what we got right there. Start with the first term. We call that t sub 1. There we go. Let's get these parallel. And then keep on adding on n minus 1 common differences. So you add on the common difference n minus 1 times. Let's make it a little smaller. There you go. That's the ideas behind the formulas. T sub n is the first term plus the common difference added on n minus 1 times. So you multiply n minus 1 times d. Hopefully this explains to you why this is n minus 1 and not n. And you can actually adapt the formula, replace the, if you noticed over here, we had a 1 here. Now I'm going to replace wherever you see a 1 with a k. So I can go from the kth term to the nth term. So now to get to the nth term, I can start with the kth term and add the common difference on n minus k times. It's a little variation in that standard formula you might be interested in, because now you can go from any term to any other term in the sequence. It doesn't have to be the first term. If you solve this formula for d, let's see what we come up with here. Oopsie. Undo. If you solve this formula for d, let's see what we come up with. First of all, let's put these terms on the other side. And make it t sub n minus t sub k equals n minus k times d. And now, let's take this whole thing, t sub n minus t sub k, and divide it by n minus k. And that should equal d. So now we've got a formula for the common difference. Let me just get a next division bar in there. T sub n minus t sub k over n minus k equals d. If this is looking familiar, it should. It looks a lot like f of x minus f of k over n minus k. It looks a lot like the slope formula. Change in y over change in x. And that's what the common difference is. Now, some formulas for geometric sequences. T sub n equals T sub 1 times r to the n minus 1. So again, to get to the nth term, that's what T sub n is all about, right? We're going to start with the first term, T sub 1. But in this case, we're not going to add on things. We're going to keep multiplying. We keep multiplying by r. Multiply by the common ratio, n minus 1 times. So find a formula for the nth term of this arithmetic sequence and graph it. So first, let's see if we can come up with our common difference. The common difference should equal the difference in any two successive terms. So that's 5 minus 3. That equals 2. We could have also done it as 11 minus 9. That equals 2. So I'm pretty convinced the common difference is 2. So there you go. Equals 3. So now we call, stop for a second here. Okay, here's our formula for the nth term of an arithmetic. And so we have all the constants we need. T sub n equals T sub 1, which we said was 3, plus n minus 1 times the common difference, which you said was 2. Now normally I don't want you to leave it like this. I want you to go ahead and distribute. So you have T sub n equals 3 plus 2n minus 2. So you have T sub n. Here's our final formula now. T sub n equals 3 minus 2 is 1, so 1 plus 2n. There you go. And you can see how it works. In fact, the formula for the odd numbers is Tn minus 1. So if you had started with 1, 3, 5, we'd have the odd number formulas. Okay, and we're going to graph this as well. So let's actually look at this split. and graph these different points on the function. We have the points here, and we're going to associate 1. The first term is 3. So let's just consider this bottom axis as our, since everything seems to be staying positive, let's just fill in a nice positive axis here. That'll be our x and our y axis, but actually we're not going to call it x and y, are we? What are the two variables involved here? Not x and y. What's the input variable? That's right, n. And the output variable is the nth term, t sub n. Okay, so now we have 1 comma 3. So 1 in here at 1 comma 3. And then 2 comma 5. And then 3 comma 7. And then 4 comma 9. And then 5 comma 11. See how nice they're lining up? Because essentially what we have here is a line. Let's get it lined up a little better. So an arithmetic sequence is a linear sequence where you're only taking a small subset of the whole linear function. The subset being those points that have x coordinates or n coordinates of positive integers. Now find a formula for the nth term of this geometric sequence and graph it. So we're going to have to get a couple things over here. First, we're going to consider, first we have to consider what's the common ratio. We've been told it's geometric. Let's find the common ratio. So, single screen. Common ratio, R, is the ratio of any two successive terms. So 4.5 divided by 3. And we get 1.5. You get the same answer if you take the 6.75 divided by 4. Let's check that on the calculators. 6.75 divided by 4.5. And you get, again, and again you get 1.5. So I'm convinced the common ratio is 1.5. So now we put our formula for the nth term. T sub n equals T sub 1 plus times r to the n minus 1. So we want to know T sub n. And we know T sub 1 is 3 times r. So let's multiply by let's call 1.5 all raised to the n minus 1. I think we're all set. N minus 1 power. Now, what could you do with this? I consider this simplified enough, but sometimes you might find that if we distribute this power and write it as 3.5 let's get some space in between here. Anyway, as 1.5 to the n minus 1, so as 1.5 to the n divided by 1.5 to the negative 1. Now, 1.5 to the negative 1, that's 3 halves of negative 1, or 2/3. If I multiply that times the 3, I get 2. So I'm actually going to get 2 times 1.5 to the n. T sub n equals 2 times 1.5 to the n power. Now that does look a little simpler, but I would have accepted this here up here as well. 3 times 1.5 to the n minus 1. Now let's see how it graphs, because we've got a few points we can put on here. And again, we'll put up our axes like we had before. We've got the, notice I'm going to use array this time, because just to emphasize the fact that we only have positive values in each direction. And we'll get a few points on there. So here we go, 1, 3, 2, 4.5, 3, 6.75, 1, 2, 3, 4, 5, 6.75. And notice how it's not quite linear, because we have a slight exponential growth here with a base of 1.5. Okay, so we can't put a line through those. Now in a geometric sequence, t sub 3 equals 12 and t sub 6 equals 96. Find t sub 11. Let's pause for a second here. Okay, so here's our first approach, a standard formula with a system of equations. That is to take this t sub 3 equals 12 and t sub 6 equals 96 to try and figure out what our formula is. Well, it's kind of like we're putting 2 points into this equation to figure out the two unknown constants r and t sub 1. The trick here is to understand how to interpret t sub 3 equals 12 here into this formula. Let me show you how that works. And we're going to put a copy over here too. But in this case, we're just looking at t sub 12, t sub 3 equals 12, and over here just the t sub 6 equals 96. And let's see how these are incorporated into the equations, because this is where sometimes students get a little confused about this notation. T sub 3 equals 12. So I'm going to take this and I'm going to write it as, we got to get out of the superscript there, t sub 3 equals t sub 1 times r to the 3 minus 1 power. See how that works there? So we end up with t sub 3, which we know is 12, equals t sub 1 t sub 1 times r to the second. Okay, that's how I get one equation. I'm going to do something similar now with t sub 6 and 96. Okay, and here's t sub 6 equals 96, and we get 96 equals t sub 1 times r to the fifth. So this is what I was talking about. We've created two equations and two unknowns. We should be able to solve for t sub 1 and r at this point. And there's a nice little trick here you can do here just by taking the ratio of these two equations. Okay? Take this equation over this equation. I'll show you on the next page. Okay, so here are two equations, and we can take the ratio of these two. So you can actually take one equation and divide it by the other equation. Let's see how this works out. Because when you do that, a lot of things cancel out. And so you get this whole thing equals 96 over 12. I believe that's, let's calculate that out. Well, 72 is 6. 8. Yeah, works out just be 8. 8. And then, I shouldn't put an equal sign there. I'm creating a whole other equation here. 8 equals, the t sub 1's cancel, and we'll get r to the fifth over r squared, which is this r to the third. Well, that worked out handy. Because now you just have r cubed equals 8, so r equals 2. Okay, that worked out pretty nice. Now we can go back and come up with what t sub 1 is by subbing to either equation. So let's take this equation and put in our r equals 2. Put r equals 2 into this equation. And when you do that, you're going to get, let's see here now, 12 equals t sub 1 times r, which is 2 squared. So that yields to t sub 1 equals 12 divided by 4 is 3. Oh. So now we have a complete equation. After all that work, we've got t sub n for this sequence here equals t sub 1, which is 3, times r, which is 2, raised to the n minus 1 power. All that remains to be done then is to take this equation and figure out what we were looking for, which was t sub 11. Right? So now we can find t sub 11. Let me do this next page. So t sub 11 the 11th term equals 3 times 2 raised to the 11 minus 1. And that's 2 to the 10th, or 1,024. So t sub 11 equals 3 times 2 raised to the 10th, which is 2 to the 10th, 1,024. You can check it on your calculators. And then we just have to do 3 times 1,024, 3,076 for our answer for t sub 11. Okay? Flange out.